similarities with Pascal's triangle. And there's quite a few different types of similarities. First thing we're going to do is essentially just build it out, right? So our very first row is 1, our second row is 1 and 1, and from there you continue with 1s on the outside and then just adding the middle terms. So 1 and 1 is 2. So we now have 3 terms. 1 on the outside, 1 and 2 is 3. And then so on. We continue this pattern, constantly just adding values, right? So 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Okay, so we have a whole bunch of rows here, and you can continue this pattern forever. Our question that was posed to us is show how the powers of 11 relate to Pascal's triangle. So we'll essentially call this row 1, row 2, 3, 4, 5, and 6. So starting with 11 to the power of 0, that is actually equal to the value of 1. 11 to the power of 1 is equal to 11. Now, technically, in this row of Pascal's triangle, this is an 11. It should be seen as 1 on 1, but it kind of has the same visual effect, right? So we continue it to the power of 2 is 121, which is essentially what those 3 digits read. 11 to the power of 3 is 1331. 11 to the power of 4, I didn't even know this one, is 14641. And we can kind of prove it here with our trusty calculator. Did we try it? Oops, no, I went a little too high there. That. Did we do 11? Yeah, 11 to the power of 4 is 14641. Okay, so it's all kind of working out. And then our next one, 11 to the power of 5, which we've already done, ends up being 161051. So 11 to the power of 5 is 161051. Now, these two things don't look like they're equal at all. But the way we're going to go about this is, first of all, we're going to take a look at how many terms are there. Well, there's 1, 2, 3, 4, 5. There are 6 terms, but our issue happens in the third and fourth term, because these are essentially 2-digit terms. So you start thinking, okay, how do I count this? Do I count this as 1, 2, and then like 3, 4, 5, 6, and then like a 7 and 8, like as if there's 8 terms? But we're going to look at it as if there's just 6 terms, okay? And here, and the reason we're going to do that is because, actually we'll keep this in red, there are also only 1, 2, 3, 4, 5, 6. There's actually only 6 terms here. So we're going to try to draw a similarity. And what we're going to do is we're going to look at the values, the numeric values of each of these numbers here. So I'm going to kind of put them on top of each other. Our ones column, so we'll call this our ones column, is the number 1 in both. So we'll use green to represent Pascal's, and we'll use our blue to represent our power here. So in the ones column, we have a 1 in both situations, right? In our tens column, okay, we have a 5 in Pascal's triangle, and we have a 5 in our power of 11. Said those kind of backwards the way I did it. Our hundreds column, okay. Pascal's triangle, we have the value of 10. So this is where we start to run into an issue. And here, our fourth value is the number 0. So that starts to become a little tricky. Thousands, we have, again, 10 in Pascal's triangle. We have a value of 1 in our power of 11. In the 10,000s, we have 6 in our power of 11, 5 in our Pascal's triangle, and finally in our 100,000s, we again have our 1 of each. Okay, so it looks like 1, 2, 3 of them are kind of checking out here. But if we were to talk about like counting with blocks, or they talk about subtraction, let's think about here. Here we're talking about having 0 100ths. Okay, so if we have 0 100ths, and here they have 10 100ths. Well, 10 100ths is the idea of 1,000. So if you think of this, think of that like it's 100 times 10. There are 1,000 of them. So I could potentially move this up into this column here. Okay, so I'm going to show this 2 ways. I'm going to show it with the multiplication way. So instead of writing 10 here, I'm going to move this 1 and add it to this column over here. So it becomes plus 1. So it looks essentially 10 plus 1 is 11. So this kind of cancels out, and we're left with 0 again. So now we've matched up. And in this column, we have 11 thousandths. Well, I don't need 11, right? We usually, because of the decimal system, decimals represent 10 digits. We have passed that. 11 is past the 10 digits. 10 digits normally run from 0. Whoops, I want that to be 0. Let's write that in black. 10 digits, the decimal system is 0 to 9. So as soon as we got to 10, we should be carrying over, okay? So 10 thousandths is 10,000. So instead of writing this 10 here, let's eliminate it. We'll put it as a 0, and we'll add 1 here again. So 0 plus 1 is 1. 5 plus 1 is 6. So we've kind of done our regrouping. So these are technically the same things now. They were just kind of represented differently in this case. Okay? So that's all that is we're just moving things forward in terms of the regrouping. That's what they're trying to say. It's hard to see, but that's what that concept is trying to say, where you can still use the 11s to show Pascal's triangle there.
It's almost like when you go all the way back to like grade 3.
Yeah, it's
doing,
like
long subtraction.
Yeah, they would
like that.
Exactly. It's very similar to carrying over with addition or subtraction when you're borrowing.
Yeah.
So let's rewrite this again. The other way we could have written this, I'm going to write it again. 1, 5, 10, 10, 5, 1. 1, 6, 1, 0, 5, 1. So this one we kind of did like addition carrying over. Here we can do some subtraction. So in the 10,000 columns, let's take one of the 10,000s. So let's reduce this by 1, so now it becomes 5. And we put it into our thousands column. Well, one 10,000 is worth 10 1,000s. I'm not sure if that's easy to see. Let me show you that. So if I take one of these, that's the equivalent of having 10 1,000s. Okay? They end up being 10,000 in the end, both of them. So when I bring this over, I'm now adding essentially 10 to this value. Okay? So I'm adding 10 here. But again, I want it to match up. So I have 10 here. 10 plus 1 is 11. I don't want to use 11. I'm going to take one of the 1,000s. So I'm taking, in this case, 1 1,000. And that's equal to 10 100s. Whoops. Too many zeros there. Can you go back? 10 100s. So we do the same thing. We get rid of this 1 here. We bring it over, and we add 10 to it. So it's not very clear. We write it all together. If we kind of rewrite this now, we now have 1 here, 5 of these. We got rid of the 1, so we have 10 in this column, 10 in this column, 5 in this column, and 1 in this column. So you could do it. This is like the subtraction version of it, and this one up here is like the addition version. So here's where we're regrouping by adding, and this is where we're borrowing by subtracting. You still end up at the same idea if you look at them as like numeric values in a unit system. Okay?